Hi, today we're gonna solve Leetcode problem 283, move zeros. It's an easy question. And it says, given an array nums, write a function to move all zeros to the end of it while maintaining the relative order of the non-zero elements. So we cannot do 0, like sort or anything. And note, you must do this in place without making a copy of the arrays. Minimize the total number of operations. So Leetcode wants us to do this without making a copy, but let's make a copy. And we can, if we solve this, and then we can solve it without the copy. So we don't go by the rules of the world. Copy equals this, and so okay, so as we make a copy, we can just do everything for I in integer in nums. If I is not 0, just put in here and we should actually make a queue. Collections dot to pop it of 1 and if copy, then we can put nums I to, else we can put nums I into 0 and return nums. Oh, we don't even have to return anything. So let's see if this works. Out of range. Oh. Int object is not so it works, and it works also. But they say we don't want to make a copy. So how are we going to do this? So one way we can do this is to count how many items, non-zero items there is, and we can just copy it to the front, and after that we're just gonna put zeros. That actually makes sense. So we don't even have to do this. We can just do this and count equals 1. And the problem with that is that we also have to make a two-pointer method that goes on if I is 0. So what I mean by that is if I is 0 in nums, then we're gonna have a pointer that pointer equals 0. Then and we cannot use this I also. We have to use this pointer. Then but it can be like 0, 0, 0, 0, and then 1. So we're gonna move the pointer while nums of pointer is 0. We're gonna move the pointer. And if the pointer is not 0, we're going to put nums I to nums pointer. And we also have to make sure that this is like a base case. If pointer is bigger or equals to length of nums, that means we're actually out of the non-zero integers. Then we'll just gonna set nums I equals 0. And let's see if this works. Wrong answer. I'll put 1, 1, 1, 1, 1. Oh, we actually forgot to move the pointer also. We also have to move the pointer after putting this 1 into it. So, and we have to continue here also. So it works, and let's submit this. Runtime error. Last executed point. List index out of. So we have one value and pointer So there is an edge case when the pointer goes out of range here. So we're gonna get the edge case as if can we actually put this here? I think we can. Let's actually try that. So what this will do is that we'll actually set count. Why are we not using count? We're not even using count. So it's gonna be something like, let's see, we're doing this 0 and we're setting the pointer to 0. And first we're gonna move the pointer to 1, and if the pointer is bigger, we're gonna set to 0 and then continue, and I is over. So I think it will work for this edge case. Indentation error. List index out of range while this is kind of strange. So I guess we actually have to use the count, because that's what we were trying to use from the beginning. And or so I should only have the non-integer numbers until count. So let's say we have 3, then it should so if this is it, we're gonna just turn count, and it's accepted, and we're done. So we're actually using it without using the. So what we're doing here is that we're applying a condition to have the pointer which is bigger or equals to length of num. So the pointer should be like going on and on and on, like for this value. So this is I, and this is P. Let's say it's starting from here, and pointer comes here, and it sees 0, and it sees 1, and it'll update this to 1. And after this, it will go here, and it will also go here. It sees 0, so it goes to 3, and counter the I will update to 3, and we go on here, and we will set this to 12, and it goes on. And normally, like pointer is like at this point, pointer is bigger than length of nums, so it will just go on updating this as 0 and 0, and we're done. So but I'm not very sure why this will not work. Yeah, let's actually figure that out. If pointer, it's not very intuitive why this is not working without that. So it's working in this case, but it's not working when we have one case. So let's actually see what's happening here. So from here, the count is 0. count is 0, and for I in range of nums, so it'll just run one time. And if the pointer is not bigger than it, so it'll just go this way. Nums pointer, it'll just go here. And I see. So this will cause a problem if there are not like enough non-numbers here. So it'll just go on and on and on. It just has like zeros inside nums, and it'll go on and on and on, and it'll have a it'll basically go here, and it'll have like so maybe if I apply a condition here as pointer smaller than length of num, then but the problem of that is that it'll constantly so it'll not stop here, but it'll have a problem here, definitely. So if I do that, I would have to get an edge case if of this, and maybe it'll work. Nums I equals nums pointer nums list index out of range. Oh, so actually I should put this after this, because this will run first. Num is not defined, so it's accepted here, but we are not getting this. Output is 1 1 0. So I think this is a problem, because let's see actually what is the problem here. So it's having 0 1 0, and we are not using count, we're using just INP, and we start, it's P, so we go here and we see 1, we update this to 1, and we go on, and we see zero, and it will go on, and if for 1 it should actually have 0. Why is it not having a 0? 1 0 1 1 1 0. pointer. I can actually comment out this because we're not even using counter at this with this method. I'm just curious why count is not working. God, really, we've spent so many time on this, but hang on with me, guys. So count is pointer nums I equals 0 and pointer plus equals 1. Pointer is 0, 1, 0. It'll so we'll just do this as and pointer plus equals 1. So pointer will actually become like not 3 but 4. If you think about it, yeah. At the end. And how about I then? And 4, it'll be 1. So okay. So it actually needs to know how many characters we have to put in. So when this is 1, when I is 1, it doesn't have the information that we should update this value to 0. So this might be not very intuitive, but if we do like 0, then it'll be actually much more easier to see. So if we look into it, like we have to make this into 0, but it doesn't have that ability because it just go on and on and on. Yeah. So if we just put 0, 1, 2, 0, it'll skip this and make this into 1 and skip this, make it into 2. But after this, like when it's in the I area, it doesn't have an information that so if we make this into 0, would this work? Maybe it'll work. 1, 2, 0, 0. Yes. So this also works. Yeah, so that means that we don't even need a count method. And this was a good practice, and we have solved it in 3 other ways. One was kind of a cheating, but we have the ultimate way to actually do this, which is using the most fancy way of it, which is using the left counter and right counter. So let's see. This is kind of similar to what we have been using, and we'll have 0 write and read into 0, and while w is smaller than nums will have if nums of r. So we'll iterate the read, and if it is not 0, we'll update it to the right. And we'll update to the right, which would be nums w equals nums r, and else, which means r is going to be 0. We're just going to advance it like once. After that, we also have to get the edge case when read r is done. So if r is bigger, this is kind of similar to the pointer method we have used. This is actually exactly same as the pointer method. The difference is that we have used the for loop before and we're using a while loop, but this is kind of more intuitive with read and write. If r is bigger or equals to the length of nums, then we're going to just make nums of w equals 0, and we're gonna increase and continue because we have to iterate it into the end. But if this is not the case, we're gonna do this. We're gonna, and as we have seen in that case, we also have to yeah, so this is done, and after updating w and r, we should update w and r also. I think this is it. Let's see if this works. And how about this? It works. And how about the other case? I forgot the base case. I think it's in the description, which is this one. It works. Submit it. So the time complexity of 01, everything is 01, and the only thing is that we used the copy array here 26 minutes ago, and after that we are using space. We're just like optimizing space at this point. And for this method, the two-pointer method, we are not even using that much space. We're just swapping, and this is not even swapping. This is just updating the later index into a previous index. So we have seen a lot of methods that, like, we have seen for loop with this, while loop with this. I basically think this is the best method to do it, but just keep in mind we can actually have a count method, and we can use that count method, and that is also fine too. Okay, that's it for this video, and have a nice day. Bye.